All right, Chapter 5 Study Guide number 33. The first thing I want you to pay attention to is that these two angles are marked as congruent, which means that this is going to be an isosceles triangle. So if those are the base angles, they sit on the same base. So let's highlight the base. If this is the base, then what are the legs of that isosceles triangle? That would be this one and this one. So those legs are going to be congruent, and so that this triangle is going to be isosceles. This is an isosceles triangle. And so because we know that those two base angles should be congruent to each other. So I can take 8y minus 16, and I can set it equal to 72. There are three expressions, and you have to know which ones that you're allowed to set equal to each other. And because those are the base angles, I can set those equal. And so what we're going to do is we're going to add 16 to both sides. And so when you do that, you get 8y equals 88. And so the value of y is going to be 11. How do you know if you did that right? Go back and plug it in. 8 times 11 minus 16 is also going to give me 72. So both of those are going to be 72 degrees, so I know I did it right. How do I find my vertex angle? Well, what I'm going to do for my vertex angle is I'm going to take 180, and I'm going to subtract off the 72 I spent on each angle. So minus 72, minus 72. 180 minus 72 is going to give me 36. And so we have 36 degrees to use up here for 9x, and so this should be equal to 36 degrees. So I'm going to take 9x and set it equal to 36, and so I divide by 9 on both sides, and when I do that, I get x is 4. You can check this by adding up 72, 72, and 36, and you do have a sum of 180 degrees. All right, what kind of triangle is number 34? Well, I'm going to pay attention to the fact that they have these legs marked as congruent. So again, this triangle is going to be isosceles. This is an isosceles triangle that's going to be very important. So here is my base, and I know that these two base angles are going to be congruent. So I can add the arcs to indicate those are my base angles. And so we don't have our vertex angle, which is the one at the top, the V at the top, the blue V, but I do have 115. And what do I know about 115? Well, 115 is a linear pair with one of these base angles. So I can do 180 minus 115. And when I do that, I get 65 for this base angle. So if that base angle is 65, then this base angle is also going to be 65. So x is 65. How do I get my vertex angle? I know that I have a budget of 180 degrees to spend in this triangle, so I'm going to subtract off the two base angles of 65 each. So 180 minus 65 is going to give me 50 degrees left for this vertex angle at the top. So y is 50 degrees. Number 35, I've got two triangles overlapping. I've got an isosceles triangle here and an isosceles triangle here. And so here is my base, and I know that these base angles are going to be congruent, and I also know that this set of base angles are going to be congruent. And so I do have some overlapping isosceles triangles. And so I also am going to pay attention to the fact that this is a right angle. This is 90 degrees for one of my vertex angles, meaning that this is also going to be a square. It's going to have 4 right angles and 4 congruent sides, the four-sided figure on the outside overall. And so if that's 90 degrees, how do I figure out what is left for the gray twins? Well, that's going to be 180 minus 90 gives me, let's see what we have left. That's going to be 90 degrees that I have to split evenly between these two angles, the y and the y. And so I'm going to divide that by 2 for y, and that is going to give me 45 degree angles for y. So 45, 45. So this is a 45, 45, 90 triangle. I can also do that since this is a square. I know that the other side is also going to be 45. So this is also going to be a 45, 45, 90 triangle as well. Okay, so x is 45 and y is 45 because we end up making this set of base angles is going to be congruent as well. Okay, so x is 45 and y is 45. That other vertex angle, if they asked you for it, would also be 90. Number 36. So number 36, we have what kind of triangle? Well, now I notice that all 3 sides are the same, not just 2, like on the last one. This is all 3, which we know makes an equilateral triangle. Well, what do we know about equilateral triangles? I know that all 3 sides are congruent and all 3 angles are congruent. And so if all 3 angles are congruent, what is 180 divided by 3? That is going to give me 60 degrees for each of these angles. So that is true of all equilateral triangles. All of these angles are 60. So if they ask me what one of those angles is, you would say 60. But they don't ask you for the angle, they ask you for the value of x and for the value of y. So what can I do to find y? Well, that expression is pointing to the 60, so y minus 10 is going to be equal to 60. So the value of y is going to be 70. What do I do to solve for x? I can set x plus 5 equal to 60. Subtract 5 from both sides, and so x is going to be equal to 55. What some people might mistakenly try to do first is to set y minus 10 equal to x plus 5. That equation is valid. It is true. Those will be equal to each other, but there's no way to solve for x or y if there's two different variables in the triangle and in the equation that you're trying to solve for. Okay, so let's keep going. Number 37, I have another isosceles triangle. So there's my legs that are congruent. Here are going to be my base angles that are congruent. I go ahead and mark those. And so this is an isosceles triangle. And so we do see that this little line right here is dividing this triangle across. And so what we're going to do is we're going to use the 110. I know that 110 makes a linear pair with x. And so together those make 180 degrees. Let me write that a little bit better. Together this is a linear pair. So what is 180 minus 110? That is going to give me 70 degrees left for x. So if x is 70 right here, then this angle is going to be 70 as well because those are going to be congruent. So x is 70. So how do I figure out what is left for my full vertex angle at the top? Well, what I'm going to do is I'm going to do 180 minus 70 minus 70. Okay, and so when I do that, let's see how much is left for that full vertex angle. That full vertex angle is going to be 40 degrees. So 40 is that whole thing. How do I find what y is? Well, y is just pointing to half of it. Whenever you take that perpendicular line is going to bisect that isosceles triangle. It cuts it in half. So what is 40 divided by 2 is going to give me 20 degrees here and 20 degrees here. So y would be 20 degrees because it's half of that full vertex angle. It's a right triangle, so there's other ways you could do that. You could do 180 minus 70 minus 90, and you'd also get 20. Okay? All right, this next triangle, number 38, let me move this. I'm not used to this thing right here, and it's making me slow down a little bit. Okay, so let's see. We've got an equilateral triangle because we've got all three. So this is going to be equilateral. What do I know about equilateral triangles? I try to put all the information I can. I know that all the sides are congruent, and I know that all of the angles are equal to 60 degrees. So this one's 60, this one's 60, and then this one's 60. They're all equal to 60 because what is 180 divided by 3? 180 divided by 3 is going to give me 60 degrees for each of those angles. Okay, so what am I going to do? I am going to figure out the value of x and figure out the value of y. And so if it asks you for just what is one of the single angles, you'd say 60, but they want to know what is x. So I can set 4x equal to 60. And so you're going to divide by 4 on both sides. And of course, you're going to get x is 15. So x has to be 15. How do I find y? Well, y makes a linear pair with 60. So together, those add up to 180 degrees. And so what do I do to find y? To find y, I am going to do 180 minus 60. So 180 minus 60 is going to give me, let me do that in green. That is going to give me 120. So y is 120 degrees because that is a linear pair with the 60-degree angle on the inside of the triangle. All right, now number 39 is interesting. Number 39, we have some overlapping triangles here. So I have an isosceles triangle, so these base angles are going to be congruent. I go ahead and mark those immediately. This base angle is going to be the same as this base angle. And so we've got a vertex angle of 64. So my vertex angle is 64. So what I'm going to do is I'm going to take my sum, 180. I'm going to subtract the vertex angle. And 180 minus 64 is going to give me 116. Now 116 is what I have to use between these two x's. And so what I'm going to do is I'm going to divide that by 2. And when I do that, I divide by 2, I get 58 degrees for each of these vertex angles. This is 58 degrees, and then this is 58 degrees. So my base angles are both 58. And then I pay attention to the fact that there's a right angle here. Well, if there's a right angle here, what can I do? I can go ahead and find z. So what is 90 minus 58? 90 minus 58 for Z is going to give me, 90 minus 58 is going to give me 32 degrees for Z. So Z is 32. The other triangle is not marked as isosceles, so we can't just assume all three are the same, or two are the same. But what I can do is use this vertex angle. The 64 is going to make a linear pair with this angle right here. And so together, those are going to, let me mark that one as different. Together, those are going to make 180. So I can put this little arc over it to show that that makes 180 total. And so what is 180 minus 64? Change colors, see if that helps. What is 180 minus 64? 180 minus 64 is going to give me 116. So this one right here is 116 degrees, 116. That was not one of my letters, but that does help me find Y. So how do I find Y? Well, together, the pink one, the green one, and the blue one should add up to 180. So we're going to do 180 minus 32 minus 116. 180 minus 32 minus 116 is going to give me 32 degrees. So that ends up being an isosceles triangle. Y is 32. So those end up being isosceles because both of those base angles are congruent. And so that ends up being an isosceles triangle as well. So I will make, you know what, let's just keep going. This problem has, I don't want to say a mistake on it, but we wanted y'all to identify the congruent sides and angles from the overlapping triangles. We really wanted y'all to see which ones were overlapping that were congruent in both triangles. So it says triangle BAE, so B to A to E, that's this right triangle right here. And then the other triangle is triangle ABC, so that's this right triangle right here. Where are those overlapping? At a full side or at a full angle? Those are going to overlap at a full side from A to B. So really what we wanted y'all to do is put that overlap right there. So we know that side AB in that one triangle is going to be congruent to side BA in the other triangle. They overlap right there. So 1, 2, 1, 2. Those are congruent. We can fill in the other pieces if y'all would like, in case you already did this problem. Who would be congruent to BE? That would be AC. And AC is going to be congruent to BE. Those are going to be the hypotenuse, but which one is actually overlapping is going to be A to B and B to A. Okay, so if you'll fix that for me, I would really appreciate it. All right, now let's look at this next triangle. Triangle SUV, S to U to V, is this triangle right here. And then triangle WUT, triangle what, is right here. Where do these overlap? At a full side or a full angle. These are going to overlap at a full angle. Both of them have a letter U in it. And so you can tell on that the one we just did, it had 2 letters in common. The one that we're doing currently only has 1 letter in common. So what is going to be the same as angle SUV? That is going to be 1, 2, 3 in order. That is going to be angle WUT. So angle WUT. Those overlap at that angle. That is what they have in common. There's 1 letter in common between those 2 triangles. So let's guess using that same method, not even looking at the picture. If this is triangle ACF and this is triangle in 42, AEB, well, how many letters do they have in common? They only have 1 letter in common. A is in common in both of them. So I'm thinking it's going to be that angle, but let's check and see. So let's find our blue triangle is ACF. Our yellow triangle overlaps and is AEB. So where do they overlap? That is going to be angle A. And so they named it angle CAF, so that is 1, 2, 3, 1, 2, 3. CAF is going to be 2, 1, 3. So we need to go 2, 1, 3 in the other triangle. That would be EAB. They overlap at angle A in both triangles. All right, so let's look at this next one using that same method. Let's just look at the letters first. We have triangle HJK and triangle FKJ. So what letters are in common? I like to go ahead and pay attention to that. There's a J in both of them, and there's a K in both of them. So you can already kind of tell it is going to be a side because there are 2 letters. And so let's look at where they overlap. Here is FKJ, is this blue triangle. Here is triangle HJK, is this yellow triangle. This makes this kind of like cool, like crown looking thing. And so where do they overlap at these 2 letters, J to K? So this segment is at the bottom of each of these triangles. If you were to break them apart, they would both have a segment from J to K. So J to K is in the blue one. That goes 1, 2, 3. That goes 3, 2. So I want to do that same thing in the other one. 1, 2, 3. We're going to go 3, 2. So that's going to be KJ. Okay. All right. I will do a new video for the proofs.